Hello, this is Dr. Brooks. You are sitting in for EDCI 349 Math Methods. Today we're talking about Chapter 9 in our textbook Elementary and Middle School Mathematics, Teaching Developmentally, 10th edition. Today's lecture is about developing basic fact fluency. By the end of this chapter, and after engaging in the embedded activities and the stimulating lecture, you, the UL college student, should be able to describe approaches to developing fact fluency, especially the three-phase strategy-based process, as well as illustrate strategies for helping students derive addition, subtraction, multiplication, and division facts, justify an effective approach for reinforcing and remediating basic fact fluency. Fact fluency is extremely important. Basic facts for addition and multiplication are the number combinations where both add-ins or both factors are less than 10. So your math facts, both addition and multiplication, is where your add-ins or your factors are less than 10. So we want to help students develop math fluency. Basic facts for subtraction and division are the corresponding combinations, and they are less than 10. For example, in the problem 15 minus 8 equals 7, you might think to yourself, well, Dr. Brooks, that isn't a basic subtraction fact because one of the numbers is greater than 10. But if you do the reciprocal or the corresponding operation to find the answer, which is addition, you would add 8 and 7, and both of them are less than 10. Therefore, this is a basic math fact. Same thing with division. 20 divided by 4 equals 5. The opposite of division is multiplication. 4 times 5. Both of those digits are under the number 10. Therefore, this is a basic math fact. Our goal is to help our students to develop basic facts fluently. And fluency is not only about speed, but it is also about being flexible, accurate, efficient, and using the appropriate problem-solving skills. Therefore, teaching and assessing basic facts must focus on all four of these components. We must focus on flexibility, accuracy, effectiveness, as well as choosing the appropriate strategies for problem solving. The big ideas from Chapter 9 is that we want students to move through the three phases in developing fluency with basic facts. We want them counting, and then moving from counting to reasoning strategies, and then moving to mastery. Instruction and assessment must help students through these three phases without rushing them. So first we'll have students counting, then we'll see students using some rationale, and then we want them to have mastery where they know those facts quickly and can answer them in 3 seconds. When students struggle with basic facts, they may need to return to the use of strategies, not just more drilling. Drilling is the least effective manner to teach multiplication. I don't know what you're thinking, Dr. Brooks, that's how we learned multiplication in school. But we realized the other day during our math lesson, when one of the students did their presentation and we had to divide and multiply, we realized that we probably didn't really concretely learn those facts, and that's because we learned them by drilling and memorization. Chapter 9 is going to show you if that is not the most effective way to teach those basic facts. Well, we've been talking a lot about building 10. Number relationships provide the basis for strategies that help students remember basic facts or figure out unknown facts. It's also easier for them to do mental math when they can build 10s. So in the problem 8 plus 6, we want to see a student decompose that, take the smaller number, divide that into parts. What I'm trying to do is build a 10 with the bigger number. So if I take 6 and break it into 4 and 2, then I can take the 2, put it on the 8, come up with 10, and then add the 4 back. When I'm able to build 10s like this and I understand the relationship between numbers, it helps students to be able to solve those problems mentally. Teaching and assessing basic facts. Developing fact fluency begins in kindergarten and it continues through middle school. Addition and subtraction begin in kindergarten and hopefully are mastered by the end of second grade, because in second grade we begin multiplication and division with them mastering it by third grade. So if you got a fourth or fifth grader who doesn't know their fact fluency, if they don't have fact fluency, that means the ability to give an answer to a basic multiplication problem in 3 seconds. This is a great chapter because it's actually going to talk about some things that you can do that are effective strategies. So first we have the developmental phases for learning basic facts. Newsflash, flashcards, and time tests are not the best way to develop fluency. Instead, we need to focus on number sense. We need to help students be able to move through the 3 phases of learning math facts. So first, the counting strategy. This is where you give them 6 items, 4 items. They count the items. They tell you that they have 10 items. You want them to move from there to reasoning, where they're able to build 10s mentally, or that at least they know that they need to build 10s. For example, in this problem, 4 plus 7, if I am building 10s with fluency, then I already know that 3 plus 7 is 10. I can simply just add that 1 and know that 4 plus 7 is 11. So you want to help them first from moving. We're moving from counting objects to using reasoning skills, because we know how to build 10s. So we can build 10s and then add on. To mastery, where a student just produces an answer efficiently. They look at 4 plus 7 and the student just knows that that answer is 11 and that they can give that to you in 3 seconds or less. Math fluency over any other skills, including verbal, spatial, memory skills, or reading ability, is going to determine their success in school. So your students building math fact fluency is going to be key to their success in school. So you, as their math teacher, are going to be instrumental, especially their early math teacher. You're going to be instrumental in how successful your students are throughout their schooling career. So we have some approaches to teaching basic math facts. Over the last century, 3 main approaches to teaching basic math facts have been used. Let's talk quickly about the pros and the cons. Back in my day, like they say, it was all about memorization. Unfortunately, memorization was ineffective. It's inefficient to think that we're going to memorize hundreds of addition facts, hundreds of subtraction facts, and hundreds of multiplication and division facts. It's inflexible because we really don't know when we're memorizing. We don't own that knowledge, and so it's inflexible in us. It's hard for us to determine which operation to use. God forbid that we embed the numbers into a problem, word problem, and we put more numbers than we actually need to solve the problem, being able to come up with the answer is a problem when you've only learned memorization. And then inappropriate applications. Students misapply the facts and they don't check their work because they haven't learned any strategies, so they don't know to subtract to see if they've got the answer right, if they've added, and vice versa. Teaching basic facts effectively. We cannot have naked numbers. We talked about that last class. Naked numbers. We need to make sure that we are using word problems, story problems, embedding the numbers into real life situations. Research has found that when a strong emphasis is placed on solving problems, students not only become better problem solvers, but also master more basic facts than students in the just a drill program where we're just doing those mad math minutes. So embedding them into story problems. Using quick images are like the 10 frames. So presenting 10 frames early and often in the math classroom is essential for teaching basic facts efficiently and effectively. And then we have to explicitly teach reasoning strategies. We need to help the students talk through how they solve problems. What are their mathematical processes? How are they thinking about that? Helping them um, reason the strategies that they chose. Why did you choose addition or subtraction, multiplication or division? Why are you making those choices? And helping the students to talk through the problem. Then on page 188, we have assessing basic facts effectively. What is wrong with time test? Hey, it was good enough for me. I took time test. I learned my multiplication facts. Why is that not good enough? First, time tests do not assess the 4 elements of fluency. You gain no insight into which strategies students are using, nor if they are flexible in using those strategies. Tests give a little insight into how efficient students are, but you don't really learn enough because the students might be using ineffective strategies for some facts while quickly going through others. So at best, all you're really getting is a sense of which facts they know and which facts they don't know. But you don't know, did they get lucky and guess? How might I assess basic math fact fluency? As you assess, remember, as you assess the students, as you test the students, there is no one best strategy for any fact. For example, the problem 7 plus 8 could be solved by making tens, or it could be solved by near doubles. And we talked about this earlier about not being so rigid when the students give us the right answer, as long as they're able to talk through the process on how they arrived at the right answer. I know that in some instances we want them to use a particular algorithm, but right here what we're talking about is, our K through second grade students who are building math fluency. We want to know how did they get the right answer, and not be so rigid as to which strategy. We just want to make sure that they are using a strategy when it comes to attacking and solving problems. So, I understand that now they're worried about using this process to make sure that they get to the right answer. But I think a lot of that is making sure that the students are using a strategy. And I think that that gets lost when teachers and school districts say they have to use this process. But it's not a process. It's a strategy. And there's several strategies. And that sometimes, just like, when it comes to all learning, sometimes we want students to use this strategy. We've learned a lot, but right now we're learning and mastering this strategy, building tens. Last week we learned about the strategy of near doubles. And so I think that when we get into our own classrooms, it's not it's they're both important. The student is getting the correct answer, but that the student is also able to tell us about the strategies that they use to get the right answers. All right, we're on page 189. We're talking about reasoning strategies for addition facts. Remember that basic fact mastery depends on moving through the three phases: counting on, using a strategy, and then mastering. The second phase, the reasoning strategy, warrants significant attention. Too often, students are asked to go through the counting phase to the memorization or the mastery phase without a lot of focus on the reasoning phase. How did you arrive at that answer? So a significant part of chapter 9 is focused on the reasoning strategies, giving students a lot of strategies so that they can find one that they're comfortable with and that they can master. Some people are better when they solve a problem. It would be easier for them to build tens. I'm one of those people. I've never think about near doubles or doubles. I don't. That's not something I think about. I'm more comfortable building tens. But I can see where somebody is more comfortable doing near doubles. Dr. Brooks, what is near doubles? Sure, because Dr. Brooks can do that. Here's near doubles. Near doubles is 6 plus 7. So we can do 6 and 6, which is a double, which is a near double, which is 12. And then we have 7, which is one more than 6, which is 13. So I could do that mentally. Could have done it the other way around, near doubles. 7 and 7 equals 14. This is one less, equals 13. But this is all things that can be done mental math. Because we spend a lot of time, K through second, learning doubles and near doubles. So that's something that another strategy that students will learn. Okay. So, reasoning strategies for addition facts. So we have the reliable counting on, one more than or two more than. If we have a problem like 7 students are on a slide, 2 more join the slide, how many students are on the slide? This is a problem where students would say, well, we already have 7. We already have 7, and 2 more come, and we have 9 students waiting. That is counting on. We also have about adding 0. Remember, this is not, adding 0 is not something to just gloss over, because adding 0 means we're adding nothing. We've talked about the importance of 0 and how students struggle with that. So you want to make sure that they understand that you would spend some time, 1 plus 0 is 1, and why it's 1. Because I had 1, I'm adding nothing to it, which is kind of redundant from an adult perspective, but a hard thing to grasp as a student, because just by the mere fact of saying adding, the students are expecting to come away with more than they started with because of adding. So you want to spend some time talking about adding zeros. There are 10 double facts from 0 to 0, 0 plus 0 to 9 plus 9. These facts are foundational, provide the basis for near double strategy. So it's important that you spend time with helping students with the doubles. What are the doubles? You know, doubles. This is important because now we're a big strategy that we're using, or they're using in the math classroom, is doubles and near doubles. Having students automatically automatically be able to look at 2 plus 2 and know it's 4. 4 plus 4 is 8. And spending time on those 10 facts. And there's some cool, if you look, using manipulatives, you want to use a chart where students can actually see, and this is really great for your disabled students too, so that they can see what the answers for the doubles are. And it also will help them develop patterns, which is another strategy, an effective way of teaching, is helping students develop, find patterns. Okay, combination of 10 is when you use a 10 frame and you've got some, so 10 frame, 1, 2, 3, 4, 5. Here's a 10 frame. How many more do I need to fill my frame? And this is a very important strategy for students, is learning how to build 10. Gives them a strong foundation. And then they can derive many facts when they can build 10. So building 10 is going to help them with addition, subtraction, multiplication, and division. Consider story situations again, such as such as there are 10 boys and girls on the bus. How many girls and how many boys might be on the bus? So here you could just give a blank 10 frame, and then you as the teacher could say, I think I've got it. Let's see. I've got a lot of markers here, but they're all the same. So here's a boy, here's a boy, and then we could say the rest would be girls. How many girls? Little kids, kindergarten can do this. And then you would attach a problem to this. And you would allow the students time to come up with a lot of variations of the ways to build 10. Then we go to 10 plus. Adding onto 10 is not an official basic fact, but in preparation for making 10, students must know combinations of 10 and 10 plus something. So you don't want to just skip over 10 plus something. So you want to make sure that you're focusing on counting on. These are effective reasoning strategies for addition. So you want to show all of these strategies to your students, teach them all, give them opportunities to use them all, and you don't want to miss. So we talked a lot about building 10s. But once we got to building 10s, we hopefully in life we get more than 10 of something. More than 10 days, more than 10 gallons of gas, more than $10. So adding to 10 is another big skill. Then making 10s. Making 10s is this problem that we looked at earlier. Let's take another problem. Plus 8. 8 is the big number, so let's decompose 5. Our goal is to make this a 10. So what two numbers can we break 5 in to help make this a 10? 2 and 3, 10 and 13. So it's important to spend time helping students make 10s. Use 10s is a recently researched reasoning strategy. This thinking process, the use of 10s, is different from making 10s, and it works for the same facts. So it works for, if you're looking on your chart, it works for all of the ways that you can make 10 or add making 10 or adding 10 to. So you can do the problem 9 plus 6. We want to use 10. So I'm going to just pretend this is a 10. And then 10 plus 6 is 16. But this is one less than 10. So I need to take that one away. Wow. That sounds like a lot. But it is a lot when you're, like I used the analogy before, when this is left-handed and you've been right-handed all the time. But this is not a lot when this is what you've been taught and this is all you know. So when you start in your very early grade levels teaching it like this, it's not so cumbersome. And remember, countries and folks who are doing math better than us and outperforming us, they're doing it like this. And 10 is just an easy number for us to manipulate mentally. So using 10, so actually replacing one of the numbers with 10 and then keeping track of what's the difference when I use the 10. I can use 5 as an anchor. Using 5 as an anchor means looking for 5s in the numbers in the problem. For example, 7 plus 6. A student may see this as 7 is 5 plus 2 and 6 is 5 plus 1, 5, 10, 11, 12, 13. Just another way for another strategy. We want to provide students with all of these strategies. And then they'll pick one that they are most comfortable with, that they find is the most effective and efficient one to use, and they may use different ones. So you want to, and when I'm teaching this strategy, of course, I'm going to want to see them only using this strategy for this problem. And so I'm spending some time talking about this because for the parents in the room or the folks in the room who have been hearing these conversations about what's going on with math, this is what's going on with math. This is how come I'm assuming this would be best practice. I'm assuming that this is the reason why sometimes they only want to see it worked a certain way, because they're trying to teach these reasoning strategies so that the student is efficient in all of these strategies, but is more effective with one or two of them because they're going to pick the one or two that really works well for them. But you want to introduce them to all of them. And then we have near doubles. I explained that before. Near doubles, they're also called doubles plus 1 or doubles minus 1. And we talked about what that looks like. It looks like, well, its double would be 4 plus 4, which would be 8, but 5 is one more than 8, which is 9. Again, seems difficult, seems like the long way to do it, but this is something that your mind literally can almost do instantaneously. Once students are effectively taught in these reasoning strategies, they can give you an answer probably in 3 seconds if they're, according to the research, if they're effectively trained in that. All right, I've been talking 30 minutes. You've been listening 30 minutes. I am now on page 186. I am going to move on from talking about addition to talking about subtraction. I think we'll take a pause right now. I'll stop this right now and then we will finish starting at page 196. Thank you.